Hello viewers, in this video lecture today we are going to talk about the module Power Generation Technologies, in which we are going to learn about lecture 3 Types of Fuel. In the previous lecture we have learned about energy scenario. So viewers, today we will deal with types of fuel. Here are the important topics which will be discussed in this video. Introduction to fuel, physical and chemical properties of coal, advantages and disadvantages of solid fuel, liquid fuel, properties of liquid fuel, advantages and disadvantages of liquid fuel. Gaseous fuel, properties of gaseous fuel, application, advantages and disadvantages of gaseous fuel. Advantages of gaseous fuels. Now, we will discuss in details. Introduction to fuel. A fuel is a material that can be made to react with other substances so that it releases energy as a thermal energy or to be used for work. The concept was originally applied slowly to those materials capable of releasing chemical energy, but has since also been applied to other sources of heat energy such as nuclear energy like nuclear fission and nuclear fusion. The main purpose of fuel is to store energy, which should be a stable form and can be easily transported to places of use. Almost all fuels are chemical fuels. The user employs these fuels to generate heat and perform mechanical work such as powering an engine. It may also be used to generate electricity, which is then used for heating, lighting or other purposes. The heat energy released by reactions of fuel can be converted into mechanical energy with a heat engine. Other times, the heat itself is valued for warmth, cooking or industrial purposes as well as illumination that accompanies combustion. Fuels are also used in the cells of organism in a processes known as cellulose respiration, where organic molecules are oxidized to release usable energy. Hydrocarbons and related organic molecules are by far the most common source of fuel used by humans, but other substances including radioactive materials are also utilized. Fuels are concentrated with other substances or devices storing potential energy such as those that directly release electrical energy such as batteries and capacitors, or mechanical energy such as flywheel, springs, compressed air or water in a reservoir. This section briefly describes the main feature of fuels. Energy from the sun is converted into chemical energy by photosynthesis, but as we know, we will burn dried plants or wood, producing energy in the form of heat and light. We are releasing the sun's energy originally stored in that plant or in that wood through photosynthesis. We know that in most of the world today, wood is not the main source of fuel. We generally use natural gas or oil in our homes, and we use mainly oil and coal to heat the water to produce steam to drive the turbine for our huge power generation systems. These fuels, coal, oil and natural gas, are often referred to as a fossil fuels. The various types of fuels like liquid, solid and gaseous fuels that are available depend on various factors such as cost, availability, storage, handling, pollution and landed boilers, furnaces and other combustion equipment. The knowledge of the fuel properties help in selecting the right fuel for the right purpose and for efficient use of the fuel. Laboratory tests are generally used for assessing the nature and quality of fuels. Fuel, when burnt, produces heat. Thus, the substances classified as fuel must necessarily contain one or several of the combustible elements: carbon, hydrogen, sulfur, etc. In the process of combustion, the chemical energy of fuel is converted into heat energy. To utilize the energy of fuel in most usable forms, it is required to transform the fuel from its one state to another, that is, from solid to liquid or gaseous state, liquid to gaseous state, or from its chemical energy to some other form of energy like single or many stages. In this way, the energy of fuels can be utilized more effectively and efficiently for various purposes. Fuel is any material that stores potential energy in a form that can be practicably released and used as heat energy. The concept originally applied solely to those materials storing energy in form of chemical energy that could be released through combustion. But the concept originally applied solely to those materials storing energy in the form of chemical energy that could be released through combustion. But the concept originally applied solely to those materials storing energy in the form of chemical energy that could be released through combustion. But the concept has since been also applied to other sources of heat energy, such as nuclear energy like nuclear fission or nuclear fusion, as well as releases of chemical energy through non-combustion oxidization, such as in cellular biology or in fuel cells. The heat energy released by many fuels is harnessed into mechanical energy like an engine. Other times, the heat itself is valued for warmth, cooking or industrial processes, as well as illumination that comes with the combustion. Fuels are also used in the cells of organism in a processes known as cellular respiration, where organic molecules are oxidized to release an unusable energy. Hydrocarbons are by far the most common source of fuel used by humans, but other substances including radioactive metals are also utilized. Fuels are contrasted with other methods of storing potential energy, such as those that directly release electrical energy, such as batteries and capacitors, or mechanical energy such as flywheel, springs, compressed air or water in a reservoir. Chemical fuels. Chemical fuels are substances that release energy by reacting with substances around them, most notably by the process of combustion. Chemical fuels are divided in two ways. First, by their physical properties as a solid, liquid or gaseous. Secondly, on the basis of their occurrence, like primary, that is natural fuel, and secondary, that is artificial fuel. Thus, a general classification of chemical fuel is, general types of chemical fuel is shown in the figure. General types of chemical fuels, it is shown in the table, like fuels, primary fuel, that is natural fuel, secondary fuel is artificial fuel. In primary fuels, classification of solid fuels are like wood, coal, peat, dung, etc. Liquid fuels are petroleum, diesel, kerosene, gasoline, LPG, coal, tar, naphtha, ethanol. In gaseous fuels are natural gases, hydrogen, propane, methane, coal gas, water gas, blast furnace gas, coke oven gas and CNG. Now we come to solid fuels. Solid fuel refers to various types of solid materials that are used as fuel to produce energy and provide heating, usually released through combustion. Solid fuels include wood, charcoal, peat, coal, hexamine, fuel tablets and pellets made from wood, wood pellets, corn, wheat, rye and other grains. Solid fuel rocket technology also uses solid fuels like solid propellants. Solid fuels have been used by humanity from many years to create fire. Coal was the fuel source which enabled the industrial revolution from firing furnaces to run steam engines. Wood was also extensively used to run steam locomotives. Both peat and coal are still used in electricity generation today. The use of some solid fuels, for example coal, is restricted or prohibited in some urban areas due to unsafe level of toxic emissions. The use of other solid fuels as wood is decreasing as heating technology and the availability of good quality of fuel improves. In some areas, smokeless coal is often only solid fuel used. In Ireland, peat barricades are used as smokeless fuels. They are also used to start a coal fire. Physical and chemical properties of coal. The physical properties of coal including heating value, moisture content, volatile metal and ash. The chemical properties of coal refer to the various elemental chemical constituents such as carbon, hydrogen, oxygen and sulfur. Physical properties like heating value. The heating value of coal varies from coal field to coal field. The typical goods carrying vehicle for various coals are given in the table. Fixed carbon. Fixed carbon is the solid fuel left in the furnaces after volatile matter is distilled off. It consists mostly of carbon but also contains some hydrogen, oxygen, sulfur and nitrogen not driven off with the gases. Fixed carbon gives a rough estimate of the heating value of coal. Volatile matter. Volatile matters are the methane, hydrocarbons, hydrogen and carbon monoxide and incombustible gases like carbon dioxide and nitrogen found in coal. Thus, the volatile matter is an index of gaseous fuels present. A typical range of volatile matter is 20 to 35%. Volatile matter proportionately increase flame length and helps in easier ignition of coal. Sets minimum limit on the furnace height and volume. Influences secondary air requirement and distribution aspects. It also influences secondary oil support. Now, we will come to ash content. Ash is an impurity that will not burn. Typical range of ash is 5% to 40%. Now, ash reduces handling and burning capacity. It increases handling cost. It affects combustion efficiency and boiler efficiency. It causes crinkling and slagging. Now, moisture content. Moisture in a coal must be transported, handled and stored. Since it replaces combustible matter, it decreases the heat per kg of coal. Typical range is 0.5 to 10%. Now, we will come to moisture. It increases heat loss due to evaporation and superheating of vapor. It helps to a certain extent with binding fines. It adds radiation heat transfer sulfur content. Typical range is 0.5 to 0.8% normally. Sulfur. Sulfur affects crinkling and slagging tendencies, corrodes chimney and other equipment such as air heaters and economizer. Limit exit flue gas temperature. Density. Knowledge of the physical properties of coal is important in coal preparation and utilization. For example, coal density ranges from approximately 1.1 to about 1.5 megagrams per cubic meter or grams per cubic centimeter. Coal is slightly denser than water, 1 megagram per cubic meter, and significantly less dense than most rock and mineral matter. Example, shell has density about 2.7 megagrams per cubic meter and pyrite of 5 megagrams per cubic meter. Now, porosity. Coal density is controlled in a part by the presence of pores that persist throughout coalification. The presence of pore space is important in the production of coke, gasification, liquefaction and the generation of high surface area carbon for purifying water and gases. From the standpoint of safety, coal pores may contain significant amounts of adsorbed methane that may be released during mining operations and form explosive mixtures with air. The risk of explosion can be reduced by adequate ventilation during mining or by prior removal of coal bed methane. Now, reflectivity. An important property of coal is its reflectivity, that is, its ability to reflect light. Reflectivity is measured by shining a beam of monochromatic light with a wavelength of 546 nanometers. Advantages and disadvantages of solid fuels. We will discuss about advantages of solid fuels. Solid fuels takes up less space than liquid or gaseous fuels. Solid fuels is easier to handle and transport. Solid fuels require fewer precautions during storage compared with other types of the solid, liquid or gaseous fuels, because it does not spill as easily, but can still ignite if splitted on a hot surface. Solid fuel is relatively stable and difficult to ignite accidentally. Solid fuel is often less expensive other than other fuels. Now, we will discuss about disadvantages of the solid fuels. Solid fuel produces less energy than liquid or gaseous fuels per unit weight. Solid fuels emit more pollutants, including particulates and carbon monoxide, than liquid or gaseous fuels. Solid fuel can create a fire hazard if not stored or used properly. Solid fuel can be difficult to light. Solid fuel can create soot and ash. Solid fuels can also cause respiratory issue because of its smoke. Now, let us discuss about liquid fuels. Liquid fuels are combustible or energy generating molecules that can be hardened to create mechanical energy, usually producing kinetic energy. They must also take the shape of their container. The fumes of the liquid fuels are flammable, not the fluids. Most liquid fuels in widespread used are derived from the fossilized remains of dead plants and animals by exposure of heat and pressure inside the earth's crust. However, there are several types such as hydrogen fuels for automotive uses, ethanol, jet fuel and biodiesel, which are all categorized as liquid fuels. Emulsified fuels of oil in water such as ornamulsion have been developed as a way to make heavy oil fraction usable as liquid fuels. Many liquid fuels play a primary role in transportation and the economy. Some common properties of liquid fuel are that they are easy to transport and can be handled easily. They are also relatively easy to use for all engineering applications and in home use. Fuels like kerosene are rationed in some countries, for example, in government subsidized shops in India for home use. Now, we will discuss about the properties of liquid fuels. Density. Density is defined as the ratio of mass of the fuel to the volume of the fuel at a reference temperature of 15 degrees centigrade. Density is measured by an instrument called hydrometer. The knowledge of density is useful for quantitative calculations and assessing ignite quantities. The unit of density is kg per meter cube. Specific gravity. It is defined as the ratio of the weight of a given volume of oil to the weight of some volume of water at a given temperature. The density of fuel relative to water is called specific gravity. The specific gravity of water is defined as 1. Since specific gravity is a ratio, it has no units. The measurement of the specific gravity is generally made by a hydrometer. It is used in calculations involving weights and volumes. Now, we will discuss another property called viscosity. The viscosity of a fluid is a measure of its internal resistance to flow. Viscosity depends on the temperature and decreases as the temperature increases. Any numerical value for viscosity has no meaning unless the temperature is also specified. Viscosity is measured in strokes, centistrokes. Sometimes viscosity is also quoted in Engel, Staybolt or Redwood. Each type of oil has its own temperature viscosity relationship. The measurement of viscosity is made by an instrument called viscometer. Viscosity is the most important characteristics in the storage and use of fuel oil. It influences the degree of preheating required for handling, storage and satisfactory automation. If the oil is too viscous, it may become difficult to pump, hard to light the burner and difficult to handle. Poor automation may result in the formation of carbon deposits on the burner tips or on the walls. Therefore, preheating is necessary for proper automation. Now, we will discuss about the flash point. Flash point of a fuel is the lowest temperature at which the fuel can be heated so that the vapor gives off flashes momentarily with an open flame is passed over it. The flash point for furnace oil is 66 degree centigrade. Pour point. The pour point of a fuel is the lowest temperature at which it will pour or flow when cooled under prescribed conditions. It is a very rough indication of the lowest temperature at which the fuel oil is ready to be pumped. Now, we will discuss about specific heat. It is the amount of calories needed to raise the temperature of 1 kg of oil by 10 degree centigrade. The unit of specific heat is kilocalorie. It varies from 0.22 to 0.28 depending on the oil. Specific gravity. The specific heat determines how much steam or electrical energy it takes to heat the oil to a desired temperature. Light oils have a low specific heat, whereas heavier oils have a higher specific heat. Calorific value. The calorific value is the measurement of the heat or energy produced and is measured either as gross calorific value or net calorific value. The difference is determined by the latent heat of condensation of the water vapor produced during the combustion process. Gross calorific value assumes all vapor produced during the combustion process is fully condensed. Net calorific value assumes the water leaves with the combustion products without fully being condensed. Fuel should be compared based on the net calorific value. The calorific value of coal varies considerably depending on the ash, moisture content and the type of fuel, which calorific value of the fuel oil is much more consistent. Sulfur. The amount of sulfur in the fuel oil depends mainly on the source of crude oil and to lesser extent on the refining process. The normal sulfur content for the residual fuel is in the order of 2 to 4%. The main disadvantage of sulfur is the risk of corrosion by sulfuric acid formed during and after combustion and condensation in coal parts of the chimney or stack, air preheater and economizer. Ash content. The ash value is related to the inorganic material or salts in the fuel oil. The ash level in distilled fuels are negligible. Residual fuels have higher ash levels. These salts may be compound of sodium, vanadium, calcium, magnesium, silicon, iron, aluminum, nickel, etc. The typical ash value is in the range of 0.03 to 0.07%. Excessive ash in liquid fuels can cause fouling deposits in the combustion equipment. Ash has an erosive effect on the burner tips, causes damage to refractories at high temperature and gives rise to high temperature corrosion and fouling of equipment. Gaseous fuels. Fuel gas is any one of a number of fuels that are gaseous under ordinary conditions. Many fuel gases are composed of hydrocarbons like hydrogen, carbon monoxide or mixture thereof. Such gases are source of potential heat energy or light energy that can be readily transmitted and distributed through pipes from the point of the origin directly to the place of consumption. Fuel gas is contrasted with liquid fuels and some from solid fuels through some fuel gas and liquidized for storage or transport. While their gaseous nature can be advantages, avoiding the difficulty of transporting solid fuel and the danger of spillage inherent in liquid fuels. It can also be dangerous. It is possible for a fuel gas to be underdetected and collect in certain areas, leading to the risk of a gas explosion. For this reason, odorizers are added to most of fuel gases so that they may be detected by a distinct smell. The most common type of fuel gas in current use is natural gas and LPG. Properties of gaseous fuels. Since most combustion appliances cannot utilize the heat content of the water vapor, gross calorific value is of little interest. Fuel should be compared based on net calorific value. This is especially true for natural gas since increased hydrogen content results in high water formation during combustion. Calorific value. Since most gas combustion appliances cannot utilize the heat content of the water vapor, gross calorific value is of little interest. Fuel should be compared based on the net calorific value. This is especially true for natural gas since increased hydrogen content results in high water formation during combustion. Now we will discuss about advantages of gaseous fuels. The advantages of gaseous fuels over solid and liquid fuels are transportation and storage of gaseous fuels are easy compared to others. High heat energy is obtained. Their quantity and temperature are easy to control. The combustion process of gaseous fuels can be carried out with a minimum piece of equipment. During the combustion process and after, deposition of ash, soot, smoke, dust, etc. does not take place. The types of equipment used for combustion remain neat and clean. Gaseous fuels need not to be heated before use. For the combustion of gaseous fuels, excess air is not required. The flue gases emitted from the furnaces can be utilized to preheat air for obtaining higher temperatures. It has disadvantages like they are highly inflammable, high storage capacity is required. Now the application it has in the sector of IC engine, boiler furnace, industrial application, domestic application, gas engine power plants, welding processes. Now let us summarize today's video session. Today we have learned physical and chemical properties of coal, advantages and disadvantages of solid fuels, liquid fuels, properties, advantages and disadvantages of liquid fuels, gaseous fuels, advantages and disadvantages. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you.